Example 3 in 7.6 says define 3 different quadratic functions in vertex form that all open downward. One function needs to have 2 zeros, or 2 x-intercepts or roots. One needs to have 1, and the other one needs to have 0 x-intercepts, or zeros, or roots. So what that means, they're all going to be opening downward. So if I draw a grid, in order for one function to have 2 zeros, that means the vertex has to be above the x-axis, so in order for it, while it opens down, to cross the x-axis 2 times. So if I say in a function a, if I want this graph to open down, I know I'm going to have a negative, so y equals, just say, -1. I need my vertex to be either negative x's or positive x's, but it has to be a positive y. So let's say -2 for my x and a +1. Here's where my vertex is going to be. So my vertex in P and Q form, so vertex form, if it is a -2, it's going to look like a +2 squared plus my y value. So that function will have a vertex at -2 and 1, and it's going to be opening downward. A quadratic function that's going to have 1 0 or 1 intercept is going to have a vertex right on the x-axis in order for it to only touch 1 time. So if we say right here, when x is 1 and y is 0, our function would look like this. It's a -1, x -1 plus 0. And that part you don't actually have to have. You could just erase your +0 so that it looks like this, or just so that you are understanding it's in vertex form, you can have your +0 there at the end. So same thing, it's going to be opening down with 1 intercept. In order for us to have 0 x-intercepts or 0 roots, our vertex needs to be underneath the x-axis as it's opening down and will never go back up and cross the x-axis. So for that one, y equals -1, it's opening down. Let's say our vertex is going to be at, let's move over a bit, 1, 2, so 4, and we'll go down 2. Can be anywhere underneath the x-axis. These are just examples, remember. So if my vertex is at 4 and -2, it's going to look like this, x -4 squared subtract 2. My graph is opening down at that point. No x-intercepts. So just to go over that again, my green graph, if my vertex or my whole graph is opening down, my vertex is above my x-axis, I'm going to have 2 x-intercepts or 2 zeros. Right here and right here. If my vertex is on my x-axis opening down, I'm only going to have that 1 x-intercept. And if my vertex is underneath the x-axis opening down, I'm only going to have, or I won't have any x-intercepts. Example 4, a goalkeeper kicked a soccer ball from the ground. It reached its maximum height of 24.2 meters after 2.2 seconds. The ball was in the air for 4.4 seconds. We need to define the quadratic function that models the height of the ball above the ground. So we don't have anything to type into our graphing calculator right now because we don't have the function. Once we come up with the function, we can plug it in to double check. But essentially, we can predict what it's going to look like. So we're kicking it from the ground. So our height will be 0 and our time is going to be 0. At 2.2 seconds, it's reaching a max height of 24.2 meters. The ball was in the air for 4 seconds. So when it came back down over here, it was 4.4 seconds. So this curve looks like this. That's what our quadratic would look like. So here we know what our vertex is. We know what our x value is, our axis of symmetry, and we know the y value at that point. So far we know it's opening down. We're going to get a negative a value, but we're not sure what it is. It's fairly, I guess our scale is pretty large, going up only by 4s for that wide, so it's hard to say if it's going to be a fraction or greater than 1 at this point, so we'll have to solve. But for our vertex, we know x minus 2 squared plus 24.2 based on our vertex form. So just like the previous videos, now I need to pick an x and y value to solve for my a, and it just can't be the same point of my vertex. It needs to be something else. So I'm going to use this point that I know. I know 4.4 and 0 is another point. So my y is 0, what's my a? If I'm at 4.4 seconds, my vertex is 2.2 and 24.2. So subtracting 24.2 from both sides, a times 4.4 subtract 2.2 is 2.2 squared. We can divide both sides by that. So that those cancel. A will end up equaling -5. So our actual quadratic function back in red will be y equals -5 x subtract 2.2 squared plus 24.2. Part B asks us, after 4 seconds, how high was the ball above the ground? So our x represents our seconds, our time in seconds, and our y was our height in meters. So we're looking for how high up. So what is my y value? We know that my a is -5 when my x is at 4 seconds. So 4 minus 2.2 squared plus 24.2. 1.8 squared 1.8 squared is 3.24 plus 24.2. 5 times -5 times 3.24 is -16.2 plus 24.2 will give us 8. So what we just solved for is when y is 8. So our answer is your height is 8 meters after 4 seconds. Your assignment is here, page 417, numbers 1 to 3, 7, 10 to 12, and 15.